what we're doing, and then this demo is actually a very short one, like 10 minutes, but Martinez told me, oh, you need to do this like 50 minutes. And that's why we said, okay, can we do this in a series of Kubernetes? So in this topic, I will talk a bit about what Kubernetes is, what the Kubernetes components are, and then the concepts, like what is the concept inside this Kubernetes, what the Kubernetes blocks, like pods, what is a pod, what's the deployment, what is a service, etc. And then I find a very interesting thing that AKS virtual node, that is a service that you can actually host a virtual node. It's called container instances. And it's actually very interesting for me, I think. And then we have a demo, but I deployed the code before this because, yeah, you know, I don't want angry the demo gods and other things. But the Azure DevOps has a problem at the moment now, connectivity issues or that kind of things. So thank God I've done this before. And then if you have questions, you can ask the questions. So my name is Osman. I'm in this industry for almost more than 20 years. I'm a senior platform engineer at HomeTrack. HomeTrack is a Zoopla company. And we are doing valuation in the market. So when you go to, you can see on the slide, there's lots of information, but in a brief explanation, if you want to buy a property, you go to the bank and you get a mortgage. And for the mortgage, you need to evaluate your home, a new home. And that's what we're doing. We have more than 10 billion data points, like the land, the property. In short, I can say this. If you want to buy something, we know the price actually, what the valuation is, all over the UK and in Netherlands. So we are the most accurate AVM on the market, and we are a fintech, by the way. We have across market coverage, and you can use us as an industry benchmark, and we have a different kind of products for everything. So what is Kubernetes? This is a very interesting thing. You know, you heard this a lot of time, and here's an explanation what Kubernetes is. It's an orchestration tool, blah, blah, blah. Lots of information you can find everywhere. The history of, oh, it was born before the times, and now it's Kubernetes, etc., etc. But I don't care that much. For me, Kubernetes is Kubernetes run application in a cluster. I found this on a Google presentation, and I like this explanation. So what is an application? Pods. That's it. You run pods on a Kubernetes cluster, and actually that's it. The rest is configuration of the pods, how you want to access the pods, what is the security, what do you want to do with the pods. And when we talk about application, you know, we have a long history about application like monoliths, and now everything goes with microservices because I don't think no one wants to run a monolithic architecture on a Kubernetes. So here, when we're talking about microservices, you know, the buzzword is not microservices. And when you run microservices, you need an infrastructure that can handle that kind of traffic, because it can go very quickly complicated. When you have microservices like this, you have lots of microservices and lots of dependencies, lots of pods, containers, etc., etc. And if you think this is not scary, look at this. You know, you see these pictures a lot. This is for, I don't know when, but if you see, there is a lot of microservices on both infrastructure, Netflix, on Amazon. And from time to time, I'm always wondering why you watch a horror movie, to go to the cinema and watch a horror movie as an infrastructure engineer. I'm only open at Google and search for microservices, and I see this, and then I begin to start to be afraid of everything, because, yeah, this is complicated. And if you do this in a traditional way, the infrastructure, it's a nightmare. But Kubernetes comes in the picture here because you can do this with Kubernetes. You can run all your microservices, expose them, deploy them, and orchestrate everything in this way, in this manner. So yeah, that's why we actually using, that's why we want that kind of orchestration tool. You know, there are lots of orchestration tools a bit like Docker Swarms and other things, but our topic is Kubernetes at the moment. So when you ask the question why, you need to look as a business, what the business actually asks us, what they want from an application. And one of the things is if they want this application to be resilient, so it should be resilient, and it should have security. Like in our company, we are a fintech, and you have lots of regulations. So security is a must. For everyone, actually, is a must, but for us, it's an extra must. It should be flexible, and you should be scale your infrastructure. In old ways, scaling was a bit of a problem. Flexibility, yeah, you buy a VM, a virtual machine, a physical host. Scaling had issues. So why Kubernetes? Kubernetes helps you for the cluster management. You can deploy and manage your cluster resources. You can schedule the containers. You can say where the container is running, on which node, on which region you want. And it has a lifecycle handler. This is actually a good thing. You can, if the pod is not secure, it can kill itself and heal itself. And that's a good thing because you want this in a specific health and a specific state. So the naming and discovery, yeah, when you see the picture before, like on the microservices page, you see there are thousands, millions of endpoints, pods, I don't know, and you cannot do this manually and do the naming and pointing to this and that. So this helps you for discovery your pods or your services. Load balancing, obviously you want an even distributed things because you have thousands or hundreds or tens of nodes. You want not burn one node with the whole traffic. So you want to load balance the whole traffic between nodes and between pods, so you can have a load balanced and high available infrastructure. So scaling makes sets of containers elastic in numbers. You can have lots of scaling options like vertical scaling, horizontal scaling, and I want to tell you later about the virtual node. It's also, you can scale this without a cluster, outside a cluster. An image repository, you want to centralize Docker container images if you're using Docker for your runtime. If you're using something else, you can also use this as inside your image repository. Obviously, you don't want to do this manually, run a Terraform code manually on your computer and then deploy. So you need a CI/CD pipeline and the workflow for this. There are lots of new technologies and techniques that you can use. There is a standard CI/CD pipelines like Jenkins, Azure DevOps, etc. But when it comes to deploy your applications, your deployments on Kubernetes, you can use GitOps like install an operator on the cluster, and you can check your GitHub repository or Git repositories and say, oh, if you did a change, update my applications. Obviously, one of the most important things, you want to have a logging and monitoring, and you want to observe what's going on inside your pod. You think you have thousands of things, and you need to understand what's going on. You have a latency. Are they connecting to these services? Are the pods talking with the databases? Or are they talking quickly or slow? Because you can see you're pinging, you have application in the standard way, you're pinging your application and say, oh, it's healthy, but it's only that application is healthy. Is the database healthy? Do you have any connection issues between, or latency issues? And one of the other problems is when you install it in a typical way, you have, for example, on Azure, you have an app services and you have databases. And obviously, they're in the same data center, but in different zones, perhaps. And you will have latency. But if you put inside the containers, inside the Kubernetes, everything is in the same place. So the latency will be an internal thing. It's not anymore a network thing. And you also can have persistent storages you can use inside this Kubernetes. But one more thing, I think it's very important when I figure out this. So if I had hundreds of microservices, how can I understand which version is the microservice is running on the whole container? Yeah, you can look inside your code, you can go to the repos and say, okay, but think about you have hundreds of repos and you go one by one and say, oh, this is the version 2, this is the version 3. But with Kubernetes, you have a Helm chart or you have a YAML files. And inside the YAML files, you have deployment things, and you can actually see everything is actually documented there. You can see that which version is running at the moment on the production, on the dev, on staging, whether we want. So let's talk about the Kubernetes components and the concepts. So if you see, I think most of the time you see this, it's similar to every architecture. It doesn't change on AWS or Google or Azure. This is how it looks. You can see we have a Kubernetes controller, we have master nodes. All of them, the master node is actually maintained by the cloud provider. The only thing you need to work is your worker nodes. So is the VM is working because you're deploying this node, and you need to see if my pod is running, is the services thing. Most of the time, your work is here, around here. When you install your architecture, you don't need to touch so much. So when I go a bit deeper, what the components are, so we have an etcd cluster. You can see it's here. It's a database. So it's a key value database, and all of the information is there. So how many pods we have, what are the state, do we have namespaces, do we have anything? And this is a closed thing, and it can only be reached by a kube API controller for security reasons. So the kube API service that I'm talking is like a traffic manager, a traffic controller. He do the central management and have lots of REST requests, modification for the pods. You want to say, I want this 10 pods, or the replication set, the controllers, I will explain later, the services, whatever you're doing, the kube API service actually doing this. It's a REST service, and you send your command to this service and make the changes. And I think you heard kubectl, kubectl, I don't know, that has a lot of names, but I want to say kubectl. Kubectl is talking to the kube API server. And we have a control manager. This is a number of distinct controls. He runs in the background, but he looks for replication, how many replicas you have, look for the endpoints, that kind of things. An extra thing is this is different from clouds to clouds because you have different configuration per cloud. The Cloud Controller Manager is actually when you expose a service to the world, that Cloud Control Manager, that Cloud Control Manager actually goes and talks with Azure, with AWS, and says, I want a load balancer. Please create me a load balance and do and expose my pods to the world. We have on the master components, the other thing we have a kube scheduler. This scheduler is for helping you for the pods, for creating the pods and collocate them to the nodes, on the worker nodes. And it can also look for the limitations because you don't want, one of the things that you should actually always put the limitation for a pod, because if you do not, one pod can kill all of your infrastructure immediately, because if you don't have limits, like saying I have an application, it needs 1 GB memory and 2 CPU cores, you need to put these limits, and the kube scheduler looks for that. And if there's a problem, it will auto-scale if you have some kind of auto-scaling in place. So on the worker node part, we have a kubelet. Kubelet is it's talking with the kube API server, and this is actually doing the whole job for the main service for regulating the modifying the pods, that kind of things, and run for the desired states, etc. The kube proxy is on the work node. It helps you to add for the pods the network, actually, the network capability, and expose the service to the external world. If you don't have that, you need to do this manually somehow. They come up with an idea and say, oh, we have a kube proxy. This will do the job. You don't care to the rest. So this is also a concept, but it's also a component. Our main thing, like we said before, our application is a pod. So pod is I think it's the most important things because our application runs inside this pod and it can have multiple containers. And even if you have multiple containers, it works like a one application. It's an encapsulation thing, and the pods has local host, has a storage, has an IP address and port range, nothing else. Because everything else will be handled, like for the network part, it will be handled by the kube proxy. If you want something else, we'll be using other services. So what a manifest, a YAML file looks like for a pod. So you have an API version. This is very important because everything doesn't have the same API version. Something has a different one. For the pod, at the moment, I think it's version 1. You need to specify the kind. What is the kind here? This is a pod. You have a metadata. Here is my name, and here we have labels. This is a very important thing that you have labels because you can put them together in a namespace or for the security part. And choose a selector. You can say this application runs with this together. You can, for example, you can say this as a label. This is my front end. This is my backend service. This is my database service, blah, blah, blah. When you combine all of them, you can put a security around this label, or you can create a namespace around this label, that kind of things. Here we're specifying a container, we're specifying a container. The name will be a MyApp container. That's the name that you can see when you run a kubectl get pods. And we have an image, and the busybox is actually, you run a command and it says, hello, Kubernetes. But this can be verified. You can create an Nginx container. You can create whatever you want, or a database in this case. So we have the pods, but the pods are not exposed to the outside. So in the traditional way, if you have something, an app service, you know the app service will be there even if it's not working. But in Kubernetes, the pods can be killed because we have an auto-healing things, and if you put the name for the pod, and if something happened to the pod, it will be deleted. So your traffic will be gone, and every time you cannot do this manually, change everything. Every time you cannot change the address to the pod. So we have a service, and when we call service, the namings are a bit weird for me to understand. Like me, if your main language is not English, but I always think this as a load balancer. So I put a load balancer service, expose my pods, and I'm using a naming, like I said, a label, and says, I want these pods running this service. And if I do this, even if all of the pods dies and changes, I still have my same service, my same IP address, the same port address, or whatever what I'm using. So it provides you a single IP address and a DNS address for this. So create an IP address, set up a basic routing for the pods, talks to the cloud manager to assign a public IP or a load balancer. This is very important when you create a service on the Kubernetes. This service talks to the cloud manager and says, oh, I need an IP address, a public IP address. Can you give me one? Can you create a load balancer because I need to have this capability that I want to make it even, the traffic should be even. So that's what it has. And a service has three types. One is a cluster IP. This is if you have an internal service and the service, the pods should talk with each other, because otherwise you don't have a connection with each other. But this one helps to talk with each other. The node port is if you need to access from a VM and do something with a port, this will help for that. And the load balancer is a load balancer, a classic load balancer. It exposes your pod, your application to the world. So how we define what's the manifest for this? So the kind is a service. We're putting a name, and here you can see I have a selector. So on the pod, we had an, if you go back, on the pod, we had a label, but on the service, we have a selector, and we're selecting in saying this application will be exposed to the internet using this port, and my target port is this. So this helps you in this, whatever this label has, whatever the application has this label, it will expose to the internet. So like I said, the cluster IP is a service as a default service Kubernetes. If you want to run this traffic between pods, this is how you can do this with a cluster IP. This will give you an IP address for here for the service, and this will talk with other services inside your Kubernetes. And it's on the manifest, you only put the type here as a cluster IP. The rest, most of the things are the same. Like you said, I have a selector, I have a type, and here are my port informations. The node port is, like I said, it's a more primitive way to get an external traffic directly to your service through a VM. If you have a VM and you want to talk with the service, this is the way how you can do this without making this external available to everyone. It's the same way how you put. The only difference is you put the type as a node port, and here we will create a node port for this. Your ports are the same, but you have an external VM port. This is the port that access to this. This is the port that access to these ports. The naming is fantastic. And the last one is the load balancer. The load balancer, the load balancer is a network load balancer. It is on AKS. This will spin up a network load balancer. I will show you when I spin up an application. By the way, I already done this, but I will show you how we can do this. And this will give you an IP address or a DNS address, and this will be exposed to internet. And here we have a cluster IP, we have a selector, and here we define the load balancer as a service type. There is another thing, an ingress is always, it's a bit confusing because it's not a service for exposing a service. It looks like that, but it's not, because it has lots of more things. Ingress is actually not a type of service, like I said. Instead, it sits in the front of multiple services and acts as a smart router. It's like a traffic manager, and you have smart rules. You can do reverse. If you need, for example, you need reverse proxies. Somehow, your customer is an old school and has an old school network capability, and they don't believe in DNS whitelisting, and they say to you, or the requirement is this way, I don't know. They say, oh, I need an IP address. Give me an IP address to your service, but I want to touch with this IP address only, talk with this IP address only. I will whitelist this address. So you can do this with an ingress. For example, I think there are lots of different ingress, but one of them is traffic, and traffic has this capability for reverse proxying, and it also has this capability for adding SSL termination, that kind of things. So that can be done with an ingress. It looks like this. You can have different endpoints, like mydomain.com/bar, go to this service, foo.mydomain.com, go to that one, bar.domain, go to this one, another one goes to that one. So you can have smart things, and you can create rules. That's a good thing. You can say this continent cannot see this countries can see that part. etc., whatever we want. So it looks, all of the YAML files, by the way, looks very similar. But here you can see the API version is different. It is not on the actual API. The kind is an Ingress, you specify the name. And if you have a backend, you have the backend names. If you have rules, for example, if the domain goes to full.mydomain.com, this will call this service name on this port. Now, if it's a mydomain.com, and if it has a path, it will go to the bar service. So you can actually shape your traffic for saying this. Oh, I have a video from media files. It should go to that service. If something else has this something else, should we go there? So one of the other things is the volumes. Volume is a storage account. It's in Docker, you can see on the slide, it has a similar thing on the Docker. So if you want to use a persistent volume, and you can set up this thing that I didn't put a code for that. One of the more important things is the namespaces. So if you have multiple, if you want to put some projects together, or if you have multiple teams, product teams, and you don't want to give them the whole access to the whole Kubernetes cluster, you can say this, oh, we have a dev team 1. This will only look for this product. So you can put everything inside one namespace and say this, I give this access to this team so they can do this, but this namespace cannot touch the other one. Or it depends on the rules. If you create rules, you can do that. You can create resource quota for this. And you can say, oh, you can only consume that much of data or CPU or whatever you're using. One of the other things is the deployment. Deployment is actually one of the most important things, because you're deploying the whole thing with your deployment script. You can set how many replicas should be running. By the way, it's a YAML file. And what is the desired state I want to run for a deployment? How many pods should be running? What are the volumes, etc. And it's also look for the lifecycle. It's made for the pods. It controls the replica sets, and it includes the functionality to update the desired states and rolling updates. You can roll back your updates with this very easily. And this is one of the deployment for Nginx. By the way, you can install lots of applications in the same deployment. This is my Nginx deployment, the deployment name. The label is an Nginx, so whatever you see, it will be named with this. I have 3 replicas. It means I will spin up 3 Nginx pods. And it looks for the match labels for the application. Like I said before, you need to have a selector for this. And the container, it's an Nginx container. The image is this, and I'm all exposing this port to outside. By the way, it's only deploying container. There are a few type of pods. One of them is a stateful set. So if you have a stateful application, this will do this. You have stick identity with this. If you have an application that you should have an identify the things, this will always make it sure that one port is running there. And if you have login on this way, it will wait until this login is finished. And then if you need to deploy something else or you want to kill it, it will kill it that way, but it will wait until this connection is broken. A replica set is, the main purpose for this is it will be control the pods, how many pods are running on that given time. And it always guarantee this. If you say, I want 100 pods running on all of my nodes, the replica sets, it always looks, if you have hundreds of pods running, and look for the health. And if it's, for example, if you're on running 99, it looks for that and says, oh, I need to install the 100th one, because this is what the state what I want. And one of the last sets is a daemon set. The daemon set is is a pod that you need to install. You say this, I want this working on every node, and it should be running every time. You cannot delete this directly. You need to delete the daemon set. And most of the time, this is using for storage daemons, like cluster Ds, set, and runs for log collection. If you have plenty or Logstash, you want to have the logs, because this will make this persistent on every node or specific nodes. And it's also good for monitoring daemons like Prometheus, Datadog agents, or New Relic agents. I think I almost finished for the slides. So there are two ways you can run something. One of them is a declarative way, and the other one is imperative way. The declarative way is like I explained these YAML files. You can create a YAML file and run with this command. You say kubectl apply. This will apply this YAML file. The other one is you can directly call an image and install it. That's the imperative way. For example, you want to run a busybox with this image, with this name, and you can run it directly. This most of the time, if you're in a business, I think you will never have this capability to run it directly something. You should be always run this behind a pipeline. Otherwise, it will be a mess, for the security reason, lots of other reasons. So the last part I want to talk is a virtual node. I'm not sure if Google or the other one has, probably they have, but this is an interesting thing, an interesting concept, because, for example, you have 5 nodes running, but you put a virtual node, and your node has a limitation. For example, your node is a small one, and you only can have 100 pods. That's it, 100 pods with 10 CPUs, 200 megabytes, gigabyte, I don't know, whatever you want, with memory. But the virtual node, you don't have a limitation. You can run whatever you want run. And you can also install some function, like a function app, like a Lambda function, that's similar things inside this, and say this, I need this. It can spin 1,000 pods. When I finish the work, get everything. And there is no infrastructure you need to deal. You only need to deploy this code in this virtual thing. And this is the concept from the virtual kubelet. So you can have your pods, that kind of capacity you can set up on this. Like I said, you have 4 nodes, and you have a virtual kubelet. So yeah, interesting times, the demo times. And I hope everything goes right. Just for checking, is everything okay? It looks okay, right? So I'm looking. Can you see my screen, by the way? And is this big enough?
Yeah, looks good.
Oh, nice. Thank you. So with these topics, I created on 3 different clouds a few Terraform files. It's a simple one, by the way, because I only want to show how the Terraform plugin works and how you can deploy the code on Azure DevOps platform. And when I started creating these files, one of my friends asked me, oh, can I use modules on this? Or can I use a standard without using modules? And I said, oh, yeah, you can. It doesn't matter how you write your code. It works every way. So I create the simple scripts. For example, for this, for AWS, I create a standard way. So all of the resources here, I didn't use any kind of modules. So I'm not publishing this. I don't know what the correct term is, but you shouldn't use that way. Because if you have hundreds of clusters, every time you need to copy and paste in these things, and it's against a dry principle. So you need to write it once, use it everywhere, and you can use some configuration. And there are lots of tools that you can use only configuration for each environment for whatever we're using, like Terraform you can use. But this is a demo, it's a simple demo. So I write this way. So I created a resource for the EKS cluster on AWS, running the service. I love the principle. I will show also how I connect these things to the Azure DevOps. But first, I'm running this way. I created this Terraform codes. I'm creating some identification roles for the policies, a cluster policy, the service policy. Then I'm creating a security group for the cluster. And then a resource for the security group. You add an EKS cluster ingress node. And then I'm creating the cluster itself, adding an IAM role, some attachments. By the way, all of the codes you can find in the GitHub repository I will share at the end of this talk, so you can find the codes. So I'm not going indeed what the code means. I want to show you how it works. So I create a simple one. This is not a production one, so please don't use that code inside your production. It's for demo purpose only. It's a simple code. So you're creating lots of roles, security groups for your node, because you also, so the one part is for the master node, the control plane. This is where your master node will work. And then you need also create the same rules, same things for your worker nodes. So here, this is for the worker node. I'm looking for the egress, what port I should use, what my CDR blocks are, by the security group rules. I want to have a 443 connection. I want to have the connectivity here. So I'm creating some security rules, the node groups, etc. So I have some outputs. If you want to run this locally and you want to have the script config files on your computer so you can run the kubectl commands, you need to have the output here. But like I said, never run on your local machine Terraform files if it's possible. You're setting your provider. So one of the things I would like to do this, I'm setting everything in different Terraform files. So when I need to update something, it's very easy to find. Normally, everything here you can use in one Terraform file and deploy it that way. But this helps me more for the visibility, other kind of things. I have a state file, so this is a very important thing. I created a S3 bucket, so I can have the state there, so I cannot accidentally deleting something when I run a new Terraform code and say, oh, it's already there. I didn't use on AWS, you're setting up an S3 packet for the state files, but for the locking, you need to lock the files. You don't want two developers running the same thing on the same Kubernetes cluster and one crashing each other. So for that purpose, you're spinning off a DynamoDB, I think it was. But I didn't add this thing for the demo here. It's expensive and it's a demo account. So yeah, I didn't use that. I'm using some Terraform TFVARs. This is for if you have different regions, if you want to deploy in different regions, you can run this way, or when you run the Terraform command, it will ask you. So I say, oh, don't ask me, please, every time, because when I start testing a Terraform file, I deploy this 10 times, testing things and deleting things. Every time I don't want to put some code there. And also I can use this on the pipelines. If you have different regions, I can set this configuration like this in a simple way. Obviously, you have the variables. And here, I created my VPC, the network, in a separate file. So you have, for the AWS, you have the VPC, and you're creating the subnets, the gateways, the route tables, and make the association for the route tables. So this was for AWS. On Azure, I used modules. Want to see if that module structure works with Azure DevOps. So I create a module folder and created every resources here. For example, this is for the AKS, this is for the log analytics, for the network, for the resource group. And if you go, you can see that all of them has a main file, an output file, and a variable. Like here, you can see this is a simple resource group on Azure. And I create this once, and I can call it from everywhere with a configuration file only. The same thing is with the network. I have subnets, I have VNets, setting up all of the needs, all of the resources I need here, and then I call it from my main file. For example, you see it's now different. On the AWS part, if you see it, you can see the resources. But here on Azure, I'm using modules, and I'm giving a source, the source of my module where I can find the modules. So I'm using a module under Azure, the resource group. So here I'm setting up the resource group name, the group location, the tags, and everything you can find here now. I'm creating the variables for everything, and then I'm creating a Terraform. Like I said, you can pass this from the Azure DevOps, or you can pass a file like this. So my resource group name will be this. I'm using this location. This is my resource prefix. My log analytics workspace is that. Blah, blah, blah. Lots of things you can set up here. And I only need to change these numbers, and it will automatically change my whole resources. So here I'm creating the subnet. Here I'm creating the log analytics workspace, the solution, and the Kubernetes structure. Like I said, my output is here. I have the provider. You need to set up the version, what provider you want to use. I created this 4 months ago, so I was using 2.0, but now I think we have 2.28 something. And we have a state file like here. The good thing with Azure is when you put this on a storage account, it will create a release, a lease for you. So it will lock the file. You don't need a DynamoDB like in AWS. It locks the file, so no one can use it at the moment. When you run this Terraform script, it locks the file, and then when you're finished, it will release the lease. So I'm saying this, I'm using this Terraform backend, it's a resource group. I'm using the storage name in that container, and this is my key. So obviously, if you're using a product, if you use this in a prod, you say this is a prod, don't use this Terraform TF state. You can use different kind of names, whatever you want with this naming scheme. You can say, by the way, for each product, you need to create a different TF state. You don't want to put everything in the same TF state. This is a very dangerous thing, so always separate everything with each other. And on GCP, on Google Cloud, I've done something differently. Yeah, I'm used modules, but here you can, on the module, you can see everything is in different module. I use a log analytics module. I'm using a subnet module, but on GCP, I tried even something different. I only create one module and run everything from here. It looks very clean. Sometimes it can be complicated, but it's clean. And when you go to the modules itself, you can see I created for everyone, everything, one file in the same folder. So if I want to, I think I need to start with the network. Here is my network resources. This is the network. Here is for the health check, if I want to time out the interval, blah, blah, blah. The region for the backend service, forwarding rules, that kind of things. Here I'm setting this subnet. By the way, you can set everything in one file, but like I said, I like this way. It looks more clean. I can find this very quickly. If I need to look for a subnet, oh, here's the subnet, and here I can see the result, even if it's 5 lines. And here's the Kubernetes cluster itself. So you see this is my cluster. I want this running on these locations. And the minimum master version. This is a very important thing because on Google Cloud today, I was run this code, I think 1 hour ago, and it failed and said, oh, Jesus. Now, before the demo, before the speech, I fucked up everything. And I said, what's going on? And I saw the versions changed. So I said, okay, let's go to the files and change the version. Somewhere I changed it, or I don't can see it now, but I think it was somewhere else. I changed the version and it was running now. So I think that's all for the Terraform files. Now let's go and see what we are doing on the Kubernetes or Azure DevOps side. So first of things is you need to create a CI pipeline because you want at the code sent to the next stage. I created actually a YAML file, but I want to show, and then delete it probably. Yeah. So this is actually very simple. I created an empty, what do you call it, an empty build, and then get the resource from my repo called the Meetup. And then I'm deploying from the master. I didn't care at the moment for anything, but it's not only running from the master, it's also running for the other modules because I have a branch specification here. It's a asterisk. So whatever you deploy, it will be run and trigger enable an integration, and it will automatically trigger a CI pipeline every time. So here I'm only doing this: copy these files into this artifact staging directory, and then publish my artifacts. Very straightforward, quite simple, and that's it. But here on the pipeline, on the CD pipeline, I created lots of environments. So you can see, by the way, those are placeholders. It's an empty thing. I want to see this is for Azure, this is for AWS, this is for GCP, and I can run this way. I created a deploy stage for deploying to these regions, and after this finish, I want to delete destroy the whole Terraform files. That's why I create also a destroy thing. But before starting this, you need to have a connectivity to connect this Azure DevOps to your cloud. So when you, before that, first you need to install a Terraform task. And this is a Microsoft task. If you go from here to the marketplace, you can browse the marketplace and you can find here a Terraform from Microsoft task. This will help you to deploy the whole Terraform code without doing some extra things, because in the old times, we were creating a Bash script or an Azure script or other Terraform scripts, and then you put your credentials inside these pipelines. Like you need some secret keys, you need some JSON files for GCP, or you need some service principles for Azure. But with this will help you to deploy the code, and without doing some extra stuff for, I don't know, doing some changing the tokens, blah, blah, blah things. This Terraform task helps you to create this connectivity, what you need. For example, AWS, if you follow for the AWS account, it will show you how you create this thing and where you can get the keys from AWS account and whatever you need. So I need an access key ID from AWS account. I need a secret access key. And then how I can set it up. For GCP, I can set up this. So it says, oh, you have a JSON file. You should get this file from there and set this account. You need the client email, you need the project ID, you need the token URI. I will show you the screen on Azure DevOps, how it looks like. And then you can install and show you how you install the other things. So when you go here for the projects settings, inside the project settings, you can find the service connection. So before you start everything else, install your Terraform tasks. This is the first task you need to do. And the second one is establish a connection. So you need to create a service connection. So when I go to new service connection, you can see I have an AWS for Terraform. I have a GCP for Terraform, and obviously I have an Azure one. So for AWS for Terraform, you need to have an access key ID. You need to have a secret access key. When you create a user and a role on AWS, it will give you that information, actually, the key, the access key ID, and other things. And you can store this here, and it will be very secure because you never will see this access key again. If you don't have the key, it's gone. You need to recreate the access key. So, and this is a good thing because you will never be asked again for these credentials. So you set up your default regions. You know, it works like this way. You need to set up a default region on AWS, and then the service connection name, etc. If we go back to GCP, it's here. You need the project ID. You know, when on GCP, when you create a project, on Azure, we have like subscriptions, and then you have resource groups. And on GCP, you have project IDs. So projects, it's like a wrapping thing for all application you're putting in one project. So for that, I share this script for getting all this credentials for GCP. It will give you a JSON file. Actually, I can show you there. Here you get the JSON files when you run this, and here you can see the project ID, private key. It's empty at the moment because I deleted it for a security purpose. A client email, a client ID, that kind of things. The authentication URI, the token URI. So you can set all of the information here, and then you can run the GCP environment now, and you can install everything with Terraform on GCP. So if I done this, so I want to also show the service principle for Azure. So if I create a new one, you use the Azure Resource Manager, go next. You can create a service principle automatically, or you can use the service principle manually, and then pour your information here. One of the things I didn't mention on Azure part, I also use Key Vault because I need the service principle to run this thing. And here, I think I used it here. I created as a data, I called the Azure Key Vault. I put the secrets there because you don't want secrets inside your pipeline, inside the Git repository, to share this to someone. So I put my old secrets inside the Key Vault and ask the Key Vault here. For example, here I need the service principal client secret for spin up this AKS cluster. So I need using here. So it's for the security purpose, obviously. So yeah, here you create your service principal ID. Then the service principal, for the service principal ID, you need to create a key. You will create a key and then a tenant ID, and then verify and run your scripts. So now we have our service connections. We have our tasks, and the rest is create our stages. So for each environment, it's actually everything is the same. First things you need to do is choose the agent. And in this case, I'm using a Ubuntu one. But even if you choose an agent, there will be no Terraform installed. For that purpose, you have two tasks. When you go here and I run Terraform, you can see I have a tool installer and I have a Terraform task. So the Terraform tool installer will install a Terraform and for a specific version. You know, on Terraform, if you're using, I think we have now the 0.13, I think, and has some changes, and you don't want to run the latest version at the moment, perhaps. So you can say this, I want to run this version on this machine. I created this 4 months ago. I used 12.3, but I think now it has 12.29 something. So there's a lot of versions you can install, but I prefer to use this one at the moment. So the only thing difference from cloud to cloud is this part. So you can see I have the name and I can choose the provider. So I have Azure RM and AWS and GCP. So if I want to run this on Azure, obviously I'm choosing Azure RM. And then you have commands. This is the same task. I can use an init for initializing the Terraform file. Then I can validate the code. I didn't do it here because I've done this with apply. You can plan it, apply it, and you can destroy this command. If you need the extra things, you can always install a bash script. Go here if you need to do something else. Also, you can do this manually, by the way. For Azure, there's an Azure CLI. PowerShell script, whatever you want to use, you can use and do something else. But with this task, like I said, you have these commands. So I'm on the init phase, I'm doing this. I'm choosing the Azure folder from my code because, you know, when you run your CI pipeline, it will drop your artifacts in a file and you can choose it from here. So here is my Azure one, here's my GCP one, and here's an AWS one. So my modules are here. By the way, you can use a different repo for the GitHub for the modules, and as a link, you can use something like git blah, 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 and the full domain and call the modules from there. But in this case, I put it in the same folder and I'm calling it from here. And then you choose your subscription. I was using that one. Your resource group for the state files. So you need to install your backend part. So I'm using this storage account, I'm using this container, and I put this in this state file for Azure. On the plan part, is the same. Choose the provider, choose the command folder and the subscription. Apply is the same. So one of the things you can do it here, create an agentless job, because you don't want always have this, you don't want go this in one part perhaps. You can say, first create these 3 applications here, do the init, do the plan, and then ask someone to have a manual intervention to see if the plan is okay, and if it's okay, approve to the next stage. But I didn't go with that. You know, there's lots of things you can do different ways. I run this directly for this one at the moment. So on AWS, it's the same thing. One of the things is, on Azure, you can actually, also here, you can actually find the resource group here. You can see, I can see all my resource groups, but somehow I don't know if I had a problem at the moment, or if there's Azure issue, Azure DevOps issue at the moment. It's not filling up, but still I can use this bucket. I can use this key. It's not a problem, but it's not filling up. If you go here, no results is found. So I put the connection, I choose my AWS provider, do the same thing for init, blah, blah, blah. For the plan, is the same. By the way, you can use arguments, like you can say I'm using a TF out or Terraform. When you use the TF out, it will write the whole thing inside a file, and when you apply this file, it will only go with these things, and it will be not a surprise doing something else. It will what it planned and will be output as a thing. So you can use arguments for that, or like you say, you have the TF plan, and you can say an auto approve for Terraform apply, or you can do some, you want to call, so you have multiple files like this TF-var files for different regions, I don't know, and you put it inside this, in this folder called variables. This is one of the ways. The other one is using variables here, and you can call it from here. I'm using for this environment, for this, run this from this subscription, run this for this region, blah, blah, blah. And obviously you can apply for the same thing. And for GCP, everything is the same. You only change the GCP provider, fill up the backend, plan it, and apply it. So I've done this before and tried a lot, but you can see it's actually there. It takes a bit of time. I think everything takes like around 10 minutes. So I did it before that thing. So now we deployed everything. And when we go to, for example, Azure, I'm going to resource groups, and you can see I have my resource group here. If you go inside, you can see I have a network, I have my Kubernetes service, the insights for the and the logs. But on Azure, this is one of the problems. It actually created 2 resource groups, and the second one doesn't use your naming convention. It's a bit annoying. For example, if you work in a big company and you have some naming this naming things. I think this will be fixed in no time, but yeah, still is a problem. But you can see the network security group is here. If you have a virtual machine scale set, it's here. And I created a service inside my cluster, so I can have a public IP address, and you see the public IP address is here. Same on AKS. You can see my cluster is here. Clusters, no, sorry, wrong place. Clusters. So you see, I have created an AKS cluster with this naming. You can see all of the information, my net compute, my networking, the subnets, the VPC, whatever I'm using. On Google, it's the same thing here. You can find I created my Kubernetes cluster. When you click on it, you can see the whole information. By the way, you also can connect, and if you run this command, you will connect directly to your cluster. I have the same capability here on Azure. If you connect here, sorry, on the cluster, if you run connect, you can see open a cloud share or on the local terminal, run this command. It will get the credential on your machine and write in a kubeconfig, so you can run directly your command, and then you can have access to your cluster. I didn't find on AKS, I don't know, it's probably somewhere here, but I didn't find it. So yeah, you can see on GKA, you can see the whole things, you can see your nodes, how many nodes it's running, etc. So yeah, the last thing for this demo is I want to deploy and run a code and see, okay, I have this, but can I run this? So on Azure, you need to get this command. And if you run this command, you will create the credential. I ran this before, so I have already this credential. But with this command, you get the kubeconfig file. And after, when I get the kubeconfig file, if I say kubectl, sorry, kubectl get nodes, of course, not doesn't run. So I have one node, kubectl get pods. Oh, actually, I run this thing, but yeah, before I show this, I have a Kubernetes file here. It's a very simple one. So it's a service. First, I'm creating a service for Kubernetes. Here's my name. Here's my type. It's a load balancer because I want this exposed to internet to everyone. And here I have a selector. So I will, if I see an app, a pod with this name, please put it on this service and run it from there. And I create a free replica. You can see I have 3 replicas. And here's my, like I said, for that thing, I have my match labels. So it will match with this name. So I can, when I run the service, it will create this application. And I found it from GitHub, Paul Bouvier, this simple application. It's pop up a page and says, hello UK Cloud Infrastructure User Group. I said, okay, nice. So when I say kubectl, I apply this way, kubectl apply. But if hello kubectl YAML, and it will create your things. At the moment, it's nothing changed. And when I say kubectl get services, because I want to get that for this service, I want to see what the IP address it has. And I see there is my external IP address. Nice. So I'm copying this and running here. And here you go. My Kubernetes page, hello UK Cloud Infrastructure User Group. It's running on Azure. And this is the pod that it comes from. I've done the same thing with AWS. So if you go to AWS, for better things, I created here some README files. So you can export the keys if you want to use it locally. And here's how I create the bucket and the README files. And here I'm getting my connection. This is an AWS CLI tool. So when I run this, I will get the kubeconfigs on my machine, so I can run the commands. When I say this, kubectl get pods, here you go. It showed me the pods, and here are my nodes running at the moment. I only created one, and if I run the services, it's the same way. And yeah, so there's my sphere equipment on AWS. And oh yeah, I need to run this. Sorry, first. Control copy, actually control copy both. Because if I run this, you know, before I run the AKS cluster, so at the moment is my default is the AKS cluster. Now I'm updating to this one. So kubectl gets nodes, and it should be AWS. Oh yeah, nice. Now you see the IP address is changed, and if I get my services, I can see that I have a long DNS name. I copied and pasted it here. So here's my infrastructure for AWS, and the same one for GCP. On GCP, I added some few more scripts because I have done everything with the gcloud CLI. So if you want to enable the services, you need to run this scripts for enabling the services. And if you need to create a service account, I run this code and create the roles. And like I said, you need a JSON file for running this locally, like that file. So if this command, it will create a JSON file for you with this bucket name. And if I need, so there's some things you need to do with the buckets, create the buckets, enable the versioning for deletion, grant access, blah, blah, blah. But the last thing is you need to connect the same way. So my kubeconfig will using the GKE environment. And now if I say kubectl get nodes, come on, and you can see now it is on this part. I can see my GKE pool nodes, and if I say kubectl get services, and here's my external IP. If I run this external IP, you can see here my GKE cluster with this pod running with that same IP address. So I think that finished my demo. And so yeah, my last slide is we are hiring for Zoopla. HomeTech is a Zoopla company, so we have lots of companies under the branding name Zoopla. So here's our branding page, and any questions? I assume there are lots of questions, and I will see. Look, where is the questions?
No, we don't. It doesn't seem that we do have any questions. So
okay.
So far so good.
Okay.
There was a question which was sent to me privately for whatever reason. So it said, in terms of traffic management, what's the difference between a network load balancer and the Ingress controller for Kubernetes?
Yeah, so the load balancer, yeah, the naming is a bit weird. It's actually a service. The type is a load balancer, and this is only helping exposing the service to the external world. It gives you an IP address, and that's it. It's a very simple thing. It says, if you hit this IP address, go to this pod. But the Ingress has more capabilities. You can have some path. You can say, if you see on the path something like slash something, slash videos, for example, or slash images, this will go to a different pod. But if you say videos, you can go with different plays, and you can set rules. and lots of other things. Actually, the Ingress is a very capable tool. You can have cell terminations. You can add some cell certificates on that part. You can use reverse proxies. Yeah, the load balancer can use a reverse proxy because you have an IP address. But with this, you can actually set rules. If I don't know, you can set a quota for the service. For the pods, you can say, oh, you only can use 100 megabytes with this ID. You can set something, look inside your header, and if you see some ID, some organization ID, and you can say, oh, this organization ID can only see that much, or only can see this service, is nothing else. So yeah, the difference is actually huge, and it's the Ingress is not a part for a service; it's a different service itself. Yeah, the naming is a bit confusing, but the service only has 3 parts. One of them is a load balancer, a node port, and a cluster IP. And the load balancer is a very simple thing.
Cool, thank you.
Thank you, David. And if you don't have questions, you can find the GitHub repository with this URL. I already uploaded the files, the Terraform files, and the presentation is also there. So if you want to use the presentation. So yeah, for the next, I think it depends whatever you want actually, but we can do another talk around how we deploy actually the code, like using Helm, Draft, or I don't know, kubectl. I don't know, we can use GitOps, do another talk on GitOps. I'm sure lots of talks goes around GitOps with operators or that kind of things. But yeah, that's all from me.
All right, Osman, thank you very much. It was a very interesting topic, and yeah, I believe that it would be interesting to hear more from a different angle about Kubernetes. Yes. So if you don't have any more questions, Osman, thank you very much for the participants. I would like to remind to buy coffee for Osman for this awesome presentation. And thank you very much, everyone, for participating. And we'll see you in the beginning of October with another meetups. Thank you.
Thanks, everyone. Cheers.
Thank you.